right, section 6.3, day 2. So elimination, as we found out yesterday, was getting exact opposites. So what happens when you don't have exact opposites? You magically make them by multiplying one or more or both equations. It's kind of like we're going to be looking at the least common denominator. So what number do you have to multiply the equations by? The first thing you have to do is pick which variable you want to eliminate. So in this case, with this first example here, I would say that we want to eliminate the y because it has the positive and the negative on it. So I don't have to worry about multiplying by a negative number. I can just multiply by a single number. And sometimes you're only going to have to multiply one equation by it. So if we look at the y variable and look at those numbers out in front, 3 and -1, in order to get exact opposites, I would want to multiply this bottom equation by 3. So the top equation doesn't change, but the bottom equation becomes 15x minus 3y equals 39. And I'm going to caution you right here because the biggest mistake that I see students make is not multiplying what the equation equals by the same number. If you don't multiply the whole thing by 3, you are changing the equation. But if you multiply the whole thing by 3, you're just rewriting it in a different form. So now we can see that we have exact opposites on the y's, and we can go through and do our addition down. And then we can solve for x, and we can get x equal to 3. Now, yesterday I also talked in the notes about pure elimination. Pure elimination would say once you have one of the variables, you go back to the original equations here and you get exact opposites on the other variable. So instead of looking at the y's, I'm going to look at eliminating the x's. And this is where the least common denominator thought process comes in. So between 2 and 5, what is the least common denominator between 2 and 5? And that's 10. So that would say I want to multiply this equation by 5 and this equation by 2 in order to get 10 on both of the x's. But because I want exact opposites, one of those numbers is going to be negative. Doesn't matter which one, but just one of them so that you get the exact opposites. So when I multiply by 5 in that top equation, I get 10x plus 15y equals 60. And in the bottom equation, I get negative 10x plus 2y equals a negative 26. So I multiplied the top equation by 5, the bottom equation by negative 2 to get these two equations. Now I have exact opposites in my x's, and I can add down and get 17y equals 34, so y equals 2. So my point of intersection is 3, 2. Okay, that's what I meant by pure elimination. You're using elimination on both variables rather than once you get one of these variables going back and substituting it. It really doesn't matter which way you do it, whether you use the substitution or the pure elimination. It doesn't matter. It just depends on which ones you're more comfortable with. Does anyone want me to stop right there so you can process that? Huh?
Eva's Wi-Fi isn't working.
Okay,
That's why she left.
gotcha.
Yeah.
Anyone have questions on this one? Okay, we'll go on to the next one then. So this next one, if we want to look at the y's, here we have the y's. If we want to get exact opposites, I would have to multiply the bottom equation by a -4. So I get negative 3x plus 4y equals 12. Negative 8x minus 4y equals positive 32. When I add down, I get negative 11x equals 44. Divide by a negative 11, and x equals -4. I'm going to, because we're working on elimination, I'm going to do the pure elimination. So if I take the negative 3x plus 4y equals 12 and look at the x variable and eliminating that, between -3 and 2, the least common denominator is 6. I already have opposite signs, so I just have to multiply this one by 2 and this one by 3 in order to get the exact opposites. So negative 6x plus 8y equals 24. 6x plus 3y equals negative 24. When I add down, I get 11y equals 0. So y equals 0. So my point of intersection is -4, 0. It's going to go through one more example. All right. Ava, which variable do you want to get rid of in this one?
The x.
Okay. Ben, if we want to get rid of x, what do we have to multiply the top equation by?
You have to multiply it by the x value and then take it into -4.
Okay, so what number am I going to multiply that top one by to get rid of the x?
You would, to get rid of the x, you would multiply it by the 3x.
Just by 3. Okay, and then to get rid of this x on the bottom one, I would multiply by 2. That will give me exact, or that will give me opposite, or that will give me the same number. I want opposites, so I'm going to take one of them as negative. So 6x plus 12y equals -12. Negative 6x minus 10y equals positive 6. Add down, I get 2y equals a -6. Y equals -3. Okay, Megan, if I'm going to eliminate the y's now, what do I have to multiply the top equation by?
5.
Okay. And Ella, if I'm multiply the top one by 5 in order to eliminate the y's, what do I have to multiply the bottom one by?
4.
Okay, what kind of 4?
For positive 4.
Okay, if I multiply the top one by a positive 5, that's going to give me a positive 20. If I multiply the bottom one by a positive 4, that's going to give me a positive 20. They're not going to cancel out, so I'm going to want to make that 4 a negative.
Oh,
Okay, does that make sense?
yeah.
Okay, so when I multiply by the 5, I get 10x plus 20y equals a negative 20. And I multiply the bottom one by negative 4, I get negative 12x minus 20y equals a positive 12. Now, when I add down, I get a negative 2x equals a negative 8. So x equals 4. So 4, negative 3 is our intersection. Okay. Questions?